Okay, good morning. So let us start today's lesson. I think this is more or less totally new for you. So this is not something that we have already discussed at all. Okay, so that's called addition and subtraction formula. That's the next section. So let me just motivate you what I mean by this. I have seen many students sometimes do these things. So for example, if you have sine A plus sine B, and then I have seen people write it as sine A plus B. Okay, so once for all, remember that this is not in general correct. It's not true in general. By the way, in mathematics, when we say that a formula is not correct, is not valid, it doesn't necessarily mean that this is always wrong. It means that there exists at least one example that falsifies, that refute that equality or that formula. So that's extremely important. For example, even I say that this is wrong, I can cook up examples that this turns out to be true. Yes, for example, if I choose A to be 360 degrees, now let me choose B to be 0 degrees. Okay, then what happens? If I calculate the left-hand side, what happens? It becomes sine of 360 degrees plus sine of 0 degrees. I expect you to be able to immediately visualize this in your head so that you don't need the formula sheet for that. So what's the answer to sine of 360 degrees? Yes? It's equal to sine 0, but what the value is? Where is 360 degrees? You imagine, you read that, because that's a sine, you need to read the y coordinate. And what the y coordinate is? It's 0. So sine of 360 degrees is 0. Sine of 0 degrees is also 0. Yes? So this becomes 0 plus 0, and then what you get for the left-hand side is 0. But now if I calculate the right-hand side, this becomes sine of 360 degrees plus 0 degrees. But what is the meaning of a pair of brackets? It gives you the priority. So the priority is with this addition. So when I add them, what happens? I have to do this addition first, so it becomes 360 degrees, and then you already know the answer is 0. So you see the left-hand side and the right-hand side coincidentally are equal. So when I say that this formula in general is not valid, it doesn't mean that you cannot come up even with one single example that this is true. Yes, is that understandable? But in general, let me just take it out. That's not the correct formula in general. For example, if I choose A to be, I don't know, for example, let us make it 30 degrees, and let me make B to be 60 degrees. And if I calculate the left-hand side, it becomes a sine of 30 degrees plus sine of 60 degrees, yes? And then, if you remember some of these numbers, sine of 30 degrees is 1 over 2, and sine of 60 degrees is the square root of 3 over 2. And then, of course, you can add them. It becomes 1 plus square root of 3 divided by 2. So that's what you get for the left-hand side. And then if I calculate the right-hand side, I expect you should be able to calculate it in your head. So what's that? It's 1, yes? Because 30 plus 60 is 90, and you can visualize 90 is up top there. And because we are dealing with sine, I just need to read the y coordinate at the point at the top, and then you get that's equal to 1. And then it's clear that these two are not equal, yes? So you see that in general that is not true. So today's lesson is that can we cook up a formula for this addition of angles? So I have two angles, I add them, addition, and then I want to calculate sine of that angle. My question is that, is there any formula that relates this expression to sine, cosine of angles A and B? Is that right? So I want to find a formula so that if I give you information about sine and cosine of angles A and B, you can calculate the exact value of this expression for me. Is that right? So that is one of the addition formulas. Of course, there are two addition formulas naturally. Why? Of course, there are three. But I don't know, for some reason the formula for the tangent is absent in the book. I will publish some set of exercises for interested students that you will see the formula for tangent as well. But in the book we have two formulas for addition, sine of a plus b, cosine of a plus b. And then we have two formulas for subtraction, sine of a minus b and cosine of a minus b. Yes, is that understandable? So let me write the formulas here. Actually, there are four formulas. All of them will be given to you in the formula sheet. So the formulas are like this. Let me write them here so that we have enough space to show them why that's correct. So number one, of course I will not prove them in this order, but let me write it in this way. I would say that sine of u plus v, if you see this, the formula is more complicated than writing simply sine u plus sine v. The formula is sine of u multiplied by cosine of v plus sine of v multiplied by cosine of u. So that is the formula. So the formula is not just simply sine u plus sine v, unless accidentally these two become equal to 1. If that's the case, yes, you will get this formula. But in general, the formula is this. And we have a similar formula for subtraction of these angles. Sine of u minus v is equal to the sine of u, sine of the first one, multiplied by the cosine of the second one, minus sine of the second one multiplied by the cosine of the first one. So these are addition and subtraction formulas for sine. We have addition and formulas for cosine as well. Let me write them down here. So number 3, cosine of u plus v. The formula is also a little bit strange. So you get cosine u, cosine v multiplied, and then if this is positive you get a negative sign, sine u sine v, and the same more or less for cosine of the difference of them. So what happens here? So this becomes cosine u cosine v plus sine u sine v. So these formulas that you see are called addition and subtraction formulas in trigonometry. Yes, understandable? Okay, of course, I don't know. I think that there should also be the proof in the book, because otherwise it is very strict. Yes, they have some kind of proof here. So yeah, that's exactly the proof that I want to follow. Yes. So we want to see why that is correct. And I will start from number 4, because if I can calculate number 4, then I will ask for your help. Using number 4, I can find all the 3 leftovers, okay? But for that one, I remember when I was teaching Math 3C, I started teaching you these 2 theorems, 3 theorems, area theorem, sine rule theorem, and cosine rule theorem, yes? So I just remind you the content of the cosine rule theorem here for you, so that I can use it if you have forgotten, so that I want to prove this one, okay? So here, what can I do here is this. So if I have a triangle, so as a reminder, let me just write it here for you. The cosine rule. Okay, I don't want to prove it and give examples about the cosine rule, but I just want to refresh your memory about that. If I have a triangle ABC, and I don't know, you denote the length opposite to this by A, this by C, this by B. So the cosine rule is actually a triple of formulas, yes? So it tells you that if you want to calculate a square, the square of this side, you can write the square, the sum of the squares of the other sides, minus 2 times B times C cosine of the angle between these two sides, which is A. Do you remember something like that when we had it in Math 3C? Yes, still we are in the frame, so I can raise it up to here. Is that understandable? So we had this formula, if you remember, from Math 3C. And even if you have forgotten, that is something very simple. So this formula enables you, you can calculate the length of this if I give you the length of this one and the angle opposite to that. If I give you this angle, this length and that length, you put those numbers here and calculate this and take the square root sign, take the square root and you get A. Yes? That's the formula. But that's the triple of formulas. If you want, you can write the formula, similar formula for B squared. So what should I write? Do you remember? So if I want to write B squared, I have to give you A and C. Then you write A squared plus C squared, and then minus 2AC multiplied by the cosine of which angle? B. The angle opposite the one that you're supposed to find. And similarly, C squared is A squared plus B squared, and then minus 2AB, and then cosine of angle C. So that's the formula that I just want you to know when I want to prove this. Why do you think this would be important? Let us start thinking about this problem. We have only one setup, and that setup is the unit circle. So if I want to say something from the beginning about sine and cosine, I have to start from the unit circle. So let me just draw this unit circle here. Yes? And then this is the x coordinate. Okay, so that's the y coordinate. Okay, can you tell me, so my emphasis here is just this one. I want to prove this one. Do you know where should I start? Do you have some idea how should I start with? Because I want to say something about the cosine of the difference of two angles. Okay, so first of all, it would be natural if I have a setup that I can see the difference of two angles in my picture. Yes? See? Yes? Okay, then, so because I need to have two angles. One of them is called U, the other one is called V. Yes? And I want to see them in my picture in a way that I can also see U minus V in that picture. So for example, what it might be, I am not very clear, but what I mean, for example, I don't know. Let us assume that this angle from here to here is U. And let me assume that this angle from here to here is V. Okay, so let me just write them with this also. I'm assuming that this is my angle V, and I'm assuming that this is my angle U. Yes? So because I have two angles, okay? So assume that this is one of them, this is the other one. In this setup, I immediately realize what is U minus V. Yes? This big angle minus this small angle is this exactly U minus V. Yes? So for example, you can immediately realize that in this setup, this is U minus V. Right? Okay. Now, can you tell me what are the coordinates of this final point? This is angle V. Can you tell me what are the coordinates? Let me call this point P. What are the coordinates? Can you tell me? What is the x coordinate of that point P? I do not expect you to give me a number. It is related to sine and cosine. Say something for the x coordinate. What is the x coordinate? It is the cosine of the angle which corresponds to the point. Which angle corresponds to this point? Angle V. So if I ask you what is the x coordinate, everyone, what's the x coordinate? Cosine of P. Yes? So what is the sine of P? What is the y coordinate of P? Sine of P. Is that understandable? That's the definition. I want to ask the same question. Let me call this point Q. So what is the x coordinate of point Q? Cosine U. And the same sine U for the y coordinate. Yes? And now let me just complete this. Let me complete this triangle. Okay, and let me give this O. So I want to work on the triangle OQP and I want to use the cosine rule. So that's the strategy. So I have a triangle OPQ, and I want to use this formula for this side PQ. Okay, so let me simplify, give them names. So if you don't mind, let me write this, for example, M, N, and P. But of course, these are equal to what? If they are equal to 1, so thus we don't need the name. So let me just concentrate on that. Okay, now can you write the formula for the cosine formula for this triangle for M? If I want to write it down, what should I write? I should write M squared is equal to N squared plus P squared minus 2 times N times P times cosine. Okay, tell me, what should I write here?
O.
No, what is the meaning of O?
U minus V.
U minus V, the green one, yes? Is that understandable? So I have to write U minus V. So that is very good, because at least I can say something about this combination that I need here. Is that clear? Well, let us continue. M squared, okay, let me just write one more step. So M squared, this is 1, because this is the radius. This is also 1. So 1 squared plus 1 squared is 2. And then 1 times 1 is just 1, multiplied by minus 2 is minus 2, and then I have the cosine of U minus V. Yes? This is on the one hand. So let me put this in the box for the future reference, okay? This is number 1. Now, forget about this. Forget about the cosine rule. Let us refresh your memory a little bit about what you learned in the Math 2C for the distance formula. Yes? So what was the distance formula? Distance formula tells you that if you have a coordinate system here, x and y, and if you have 2 points A with coordinates x1 and y1, and you have another point with coordinates x2 and y2, if I want to find the distance between these two, I have a formula. And what was the formula? You remember? It is
X.
square root of
X.
the difference between x's. In which order it is not important, because I have an even power. And then the same thing, y1 minus y2 squared. Yes, so you remember that. So if I raise it to power 2, then I will get rid of this square root sign. Okay? So let me write m squared using this formula. So if I ask you what is m, you would say m is the distance between the point P and the point Q. That's the distance between m and q. And I want you to use the distance formula for me to write m squared. Okay, can you tell me, what can I write? So I would say, if I want to be precise, I would say, on the other hand, using the distance formula, don't hesitate to write, okay? You don't, so people think that mathematics is just about symbols and things like that. No, you have to write a little sentences. Using this distance formula, we have, okay, now help me to write this. M squared is equal to, what can I write? I have two complete squares, yes? That's the structure. Do you agree? Because if I write d squared, then I will get rid of this. It becomes x1 minus x2 squared plus y1 minus y2 squared. Yes? Okay, just tell me what happens there. Yes? Yeah. Yes? Yes, because the difference of x coordinates, so that is cosine u, cosine v. And of course, the next one would be the difference between sines, yes? Because the y coordinates. Okay, so let me just do that. So on the one hand, using the cosine rule, we have that. On the other hand, using the distance formula, we have that. But let me simplify this, because I can simplify it a lot. So let me square it by using the formula. So what is the square of this one? I have a binomial squared. It becomes the first one squared. 2 times the first one times the second one, plus the second one squared. And then I will do the same thing for the second one. So it becomes the first one squared. 2 times the first one times the second one, and then plus the second one squared. Yes? Can I simplify this a little bit more? Any questions so far? So I wrote the distance formula. I used very simple algebra using the squaring pattern. I expanded the first pair of brackets and the second pair of brackets. But can I simplify it a little bit more? This should come immediately. I don't understand why you don't see it because of this memory. You have to change the way that you think about the problems. There is a very, very famous combination here. Yes, what's that?
1 by...
Yeah, so sine squared u here and cosine squared u here. You need to take a lesson why I couldn't see it under 1 second. Yes, you should be able to train. So this is the only formula I ask, please memorize it, okay? And actually, now I understand you actually have it in your memory at least. But here and that one is 1. And this one and that one becomes 1. Yes? Is that understandable? So here I will actually say that this one, cosine squared plus sine squared of the same angle, is the most famous combination in trigonometry. Yes? Have it in mind. And then this one and that one gives me another 1. So a 1 is coming from this combination, another 1 is coming from that combination, so if I add them it becomes 2, yes? And then you see there is a 2 here and there is another 2 there, okay? Okay, let me write it in 2 steps. So I would write 2, and then I will have minus 2 cosine u, cosine v, and then I will have minus 2 sine u, sine v. So this is m squared on the other side, okay? So let me write it in. So let me write it in this way. So therefore, m squared is this guy. Yes. So this is number 2. But I have calculated the same quantity in 2 different ways. They have to match. Yes. Because m squared on the one hand is this, on the other hand is this. But m squared is the same thing. So these 2 should be the same. Yes. So I compare number 1 and 2, and then I get this conclusion that let me write it in this way. So 2 minus 2 cosine u minus v is equal to 2 minus 2 cosine u cosine v minus 2 sine u sine v. Yes? Now I can do a lot of simplifications, but at this point we are very, very happy, yes? Why? Because we are getting close to this combination. At least I get cosine u, cosine v, I get sine u, sine v. These are exactly the combinations that I like to have. And I have also cosine u minus v, so life is beautiful now, yes? So what we can do here, we can simplify these 2 from the other side. So I take these 2 in my head to the other side, for example, it becomes negative, we'll cancel that one. And what is left for me? A minus 2 is left for me as a coefficient here, and minus 2 will be left for me as a coefficient here, and the same is true for here. So what can I do at the end? I divide everything by minus 2 and I have my formula, yes? So I just explained this orally, okay? So I just take these 2 from the left to the right, so they are cancelled, then I divide by minus 2, I have my mysterious formula, yes? But the problem is that it's not midnight, yes? It was more interesting if you do it in midnight, yes? And by the way, and then you see why it turns out to be positive. Because if I divide by minus 2, this becomes positive, and both of them simultaneously become positive. So even though this is negative, but I will end up with the positive sign at the end. So that is my formula. Okay, so this is the proof of why this formula is correct. Yes? I will not ask you for the proofs in the exam. Okay, even though it's included in the book. But I really want you, because it is not fun, I just give you a list of formulas and say that use them. It's not mathematics. You need at least to see where these formulas are coming from, and that's up to you if you really want to understand them forever or just understand them once and forget them and use them. That's up to you. Okay? One question is, can you tell me what is the core? I just want you to understand this. What is the core of this theorem? There is a very famous theorem. If you take it away from mathematics, this will collapse. What that theorem is? I want you to understand these deep connections. So this is constructed, this formula wouldn't be there if that famous theorem was not there. And what is the famous theorem? What's that?
Pythagoras Theory.
Pythagoras theorem, yes? So if the Pythagoras theorem is not there, this formula will collapse. Why? First of all, I use this formula. So this formula is coming from the Pythagoras theorem, yes? Another thing, I use this formula. If you go back to my lectures in Math 3C, you realize that we use 2 Pythagoras theorems, or 3, I don't remember, to be able to prove this. So this is based on Pythagoras theorem. That is also based on Pythagoras theorem, and I use these 2 heavily in my argument. So this is based on Pythagoras theorem. And so that's a really, really important theorem in mathematics, yes? Even though when you see it in this way, you immediately do not find any connections, because Pythagoras theorem usually is related to square roots, second powers added together or something, but you do not see any second power here. Okay, so we started and proved the last one. What is your suggestion for proving the third one? Do I really need to start everything from scratch once more for that setup? Or there is a shortcut to it? Okay, so you can think until that I am cleaning this. These whiteboard markers are very nice to write, but it's very hard to clean. Yeah, unless it is left for a while, I think. So I will keep the formulas here, and let me remove this. By the way, let me just use the chalkboard today. Yes, let us start some nostalgia, yes? Yeah, we don't need to clean anything. Let's see where we are. Yeah, good. Okay, so what is that? Okay, so let me bring it so that it is in the frame for the moment. So my question is that, what do you think we can do for number 3? One hint is that you don't need to do anything very serious like this at all. You can use number 4 to prove number 3. How? Now, this is something that I want you to learn once for all. It's not hard, yes? So, because addition and subtractions are actually the same thing. They cannot differ so much, yes? What do I mean? So let me just write it here for you. Let us see how it goes, yes? So if I have cosine, it reminds me of my teenager, you know? Cosine of a u minus v. No, cosine of u plus v, that's the question. But u plus v can be imagined as a difference. Yes? How? 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 Yes, u minus v. Yes? But let me give it a name. Let us assume that minus v is what I call capital V. And then I replace it there. So what will happen? So it becomes cosine of u minus capital V. Yes? But I have a formula for that. I just showed it here. But instead of little v, I have the capital V instead. So I replace it in number 4. So it becomes cosine of what? Cosine of u cosine of capital V, yes, and then this is minus according to my formula, this becomes positive, sine of U, and then I will have sine of capital V. Yes? And now I replace it back. So this becomes equal to cosine of U, cosine of what? Minus V, plus sine of U, sine of minus V. But now you remind yourself of what we talked in the previous sessions under the title of the trigonometry of opposite angles. Yes? So we have a formula. What is the cosine of negative V? How it is related to cosine of V? How? Just imagine it. At least you can improve your imagination. Yes? It's equal. What about sine of minus V? It's opposite. Yes? So cosine of negative V, if you go back and see that lesson, you see that cosine of minus V and cosine of V are exactly the same. So I would write cosine of V. But sine of minus V is negative of sine of V, and then that negative sign goes back here, it becomes negative. So you really don't need to start from scratch anything, yes? That's the proof. Cosine of U plus V is equal to, up to this guy, so that is number 3. Now I want to ask your understanding, how we can prove number 1? You don't need to start from scratch anymore. By the way, starting from scratch is probably a little bit harder because we do not have a nice rule for sine. Yes, do you remember the sine rule was this? In trigonometry, the sine rule was if I have this, A, B, C, and then I have A here, C here, B here. Do you remember that was the formula? A over sine A is equal to B over sine B is equal to C over sine C. Yes? So this is also, of course, true, but it doesn't seem helping for proving the other one. But my question is that you really don't need to do anything very serious. If you have done your homework so far very good, you should be able to deduct actually number 1 from these. So what I want to write is this. So I want to write a formula for sine of U plus V. What do you think I will do? I don't want to start from scratch anything. I just want to use the previous formulas to be able to write the formula for sine U plus V. And that's also the second important formula. Please try to remember that. So take on lesson. Remember that combination sine squared plus cosine squared of the same angle in mind. That's always equal to 1. That's a very famous one. Yes?
Can you use like the trigonometric ettan to solve that?
What?
Trigonometric ettan, so that sine.
No, if might be you can find a way. Trigonometric ettan, what's the translation of that? Unit circle or something?
It's the like sine to the power of 2b plus cosine to the power of 2b.
Yeah, that's probably one way to do that. Yes, because I want to know something. I want to know about sine. So you write sine squared. So what you said is correct. So what you do here, you say that sine squared of U plus V plus cosine squared of U plus V is equal to what?
1.
Is 1. Yeah, that is completely true because of that famous combination. And you might say to yourself that I already discovered what is the formula for this. So in principle, I can move that to the right. And then after simplification, I take the square root and find sine of U plus V. This is really, really important to have in mind. But this has some technical and algebraic problems. So that makes the problem harder. One thing is that I have to start working with the squaring things, yes? So it means that if I want to write something for this, I have to come here and square this combination to power 2, which becomes the first one to power 2, the second one to power 2, 2 times the first one times the second one becomes 2 cosine, cosine, sine, sine. It is possible, but algebraically it becomes hard. This is one drawback of this method. Another drawback, what is the other drawback? Even if I succeed to do the algebra perfectly fine, then at the end, because I want to find the formula for sine u plus v, I have to take the square root. And when I take the square root on the right hand side, I have to put plus and minus and discuss which one is acceptable. Okay, so that's the two drawbacks of this method, even though technically it works. I believe it works. Okay? But there is another way. Remember this. If you want to find a connection between sine and cosine, one of the important formulas is, as you said, this Etton formula. But there is another very simpler connection between sine and cosine.
Sine divided by cosine is tangent.
Okay, that's a relation with tangent. No, I just want to keep sine and cosine. Come on, this is very, very famous. I talked about this a lot. If two angles add up to 90, the sine, one of them is cosine, equal to the cosine of the other one and the other way around. Yes? It's very, very important to remember. There are two ways that we can connect sine and cosine together. One of them is this famous formula. The other one is this rule. That sine of an angle is cosine of the complement angle and the other way around. Yes? So here, for example, if I want to write something in terms of cosine, I have one way that, but I just don't want to follow that because of technical problems that I mentioned. But I can write this is equal to the cosine of 90 degrees minus u plus v. So first of all, do you agree with what I have written on the board? Because if I ask you what is the relation between this angle and that angle, what is the name of this pair of angles? They're complementary. Why? Because they add up to 90. So if they are complementary, I knew from my previous studies that the sine of one of them is equal to the cosine of the other one. Is that right? But I can do it. Can you tell me what should I do? Because somehow I want to be able to use those formulas discovered before. So what can I do here now? Okay, one more hint. I can write it as cosine. Do you agree with me that I can write it as 90 degrees minus u and minus v? Is that understandable? Yes or no? Yes? Do you agree that this one and this one are equal? Yes, because what I have done, I have multiplied the negative sign in. It becomes negative u. I have written it with 90. And then I will have negative v again here. Understandable? Now what can I do here? What is my strategy? Do you see what I am heading to?
Using the fourth formula.
Yeah, can you tell which formula?
The one you proved.
Okay, how? By naming. Yes, you are right. But by naming this capital U, for example. Yes? So then read it. It becomes cosine of u minus v. Do I know the formula for cosine u minus v? Yes, that's number 4. Yes or no? So I can use that. So what is the formula? Just you can read it from there. So this becomes equal to the cosine of u, capital U, cosine of little v. This is minus, according to the formula I have to write plus. And then I will write sine of capital U multiplied by sine of v. Yes, so if I want to insist, this is formula number 4. And then I replace it back. So it becomes cosine. Instead of u, what can I write? I can write 90 minus little u, cosine of v, and then plus sine of 90 minus little u, and then sine of v. Okay, one more step, we are done. Tell me, what can I write instead of this combination? Sine of u. So this becomes sine of u, cosine of v. And then this becomes cosine of u, sine of v. So let me write it the other way around. Sine of v, cosine of u. So this will bring you the third formula in my list. The first one. The third one and the fourth one are done. I hope that you know now what to do with the second one. what should I do with the second one? What should I do? Do not disappoint me. What should I do? This is simple, yes? We just did it. How did we go from cosine of u minus v to cosine u plus v? Now I want to say something about sine u minus v. No, I have to write it myself. Okay, so sine of u minus plus minus v. Yes, that's the same trick. So I'm using the tricks over and over again. So that's why sometimes you feel mathematics is hard, because you don't pay attention to these small points. So you see, I am using this idea twice in this problem. Okay, the first one you didn't do that, but you should take lesson why I couldn't. So this is the same trick. So you see, I'm using the same trick twice in this problem. Yes, that's the point. And then I can call this one capital V. But which formula now I can use on my list? What's the number of the formula that I want to use to continue?
The second one. The first one.
No, the first one. Yes. So the first one tells, because that's u plus v. So this becomes sine of the first one, cosine of the second one, plus sine of the first one. The second one, cosine of the first one. But then I replace v with negative little v, so this becomes sine of u cosine of negative v, and then I have plus sine of negative v, and then I have cosine u. But again, the same story. Cosine of negative v is equal to cosine of v. Sine of negative v is negative sine of v, and I will get my formula back. So this becomes sine of u cosine of v minus sine of v cosine of u. So hopefully now you understand. So we started from the last one using Pythagoras, using the distance formula and the cosine rule. But the other three, we really didn't need to start from scratch. We just used number 4 and our previous knowledge about complementary angles and the trigonometry of negative angles. That's what we need actually to prove all of them. So is that right? Yes or no? Yes. Now, I don't know, the bad point about this book is that that table is not in front of you guys. So have you seen that there is a formula of these famous angles? They are really needed, and this will be given to you in the formula sheet. So I don't know. So might be you can refer to your own notes. Okay, I want to give you some examples now. So example. Determine the exact value so I emphasize here the exact value of the following items, yes? So number 1. For example, can I calculate the exact value of sine of 15 degrees now? So you know that 15 degrees is not one of the famous angles that we have it in that table. Okay? And then we learn something. So for example, 150 degrees was not a famous angle, but we were able to calculate its sine and cosine using supplementary angle theorem, yes? But even supplementary angle or complementary angle doesn't work here. For example, supplementary angle theorem tells you that sine of 15 degrees is equal to sine of 165 degrees. But the problem is still standing because I don't know what is the sine of 165 degrees. And the complementary angle theorem is valid still, but useless. Because sine of 15 degrees is equal to the cosine of 75 degrees. But again, what the cosine of 75 degrees is, I don't know. So this is not useful for this case. So this theorem tells you that you can calculate this exactly, but can you tell me how?
Sine of 60 minus 45.
Yes, sine of 60 minus 45. Yes, is that understandable? So let me change my color and write it. No, I think that the white is probably better in chalk. So here, if I want to write it, I can write it in two different ways. As Dennis said, we can choose 60 and 45. In this case, there is another pair in our list that can be useful. What is that pair? Because the famous angles in trigonometry are 30, 45, and 60. So you chose 60 and 45, which is valid. But there is another choice here, 45 and 30. So it doesn't matter if you want to use that pair or this pair, you will get the final answer the same. So here, then I have that formula on the board, yes? So this becomes the sine of the first one, cosine of the second one. I'm just using each formula number 2. And then it becomes minus sine of 45 multiplied by cosine of 60. And then I have these numbers in the table. You don't need to memorize them. I have it in my memory. So this becomes the square root of 3 over 2. And then multiplied by square root of 2 over 2. And then the same thing for this, square root of 2 over 2 times 1 over 2. So the denominator is 4, the denominator is 4, so I write the common denominator 4. Square root of 3 times square root of 2 is a square root of 6, and then a square root of 2. And that's the answer. The good point about the Casio calculators, I don't know if you have Casio calculators, one of you, please just punch this in your calculator. I think that the Casio calculator will give you exactly this form. But the point with Texas Instrument is that you get a lot of decimal points, and I don't know how to fix it. You can probably read the manual yourself. And then what you get is an approximation for that. Approximation is not acceptable in this problem. I want you to give me the exact value. Yes? Divide by 4. Because, yeah, this is multiplication, that's multiplication. Yes? Which one? This one? Yes? Do you have Casio calculators? Anyone?
Yes.
Does it give you this exact value or no?
Approximation.
Let me see. No, if that's approximation, you should be able to fix it.
Yes, that's.
I don't know, but you can read the manual. If you don't have the manual, you can find it on the internet. Because I know the Casio calculators are capable of doing this. Yes? Is it Casio? Okay, how did you fix that? Because this is very important. Of course, I will not allow you to use your calculator in my exams, but anyway. Okay. So yes. So then it's actually Martin is saying that you can go to setting and change it to fractions. If you do that, you will get this one. But I think in Texas Instrument it should also be possible. Might be more advanced ones. I don't know. Do you have Texas Instrument? When I was passing, I saw something. How does it answer?
It says square root of 3 minus 1.
But that's also correct. So the answer that provided is here is this answer. Why is that the same answer? So what was your name? Nabila. So Nabila's calculator is Texas Instrument, a little bit more advanced one, and it shows this answer. That's also acceptable. That's also an exact. But are these two numbers the same? They are the same, yes? Because if you multiply this inside, square root of 2 times the square root of 3 is the square root of 6, and the square root of 2 times 1 is the square root of 2 divided by 4. So it's also in factorized form, yes? So anyway, so you see that now we can calculate the sine and cosine of some of the other angles exactly, yes? So that's good. Okay, let me go back here and try to write a formula. Let me see what is the level of the exercises in the book. They shouldn't be that hard. Okay, so there is a very nice example in the book. So let me just, I don't know the numbers, but let me just cook up an example in that line. Okay, so let me write example here for you. This is a very important example. So let me emphasize on it by writing important, okay? Because first of all, it is mentioned in the book. Secondly, it's a really nice problem. Okay, so I will pick another numbers for myself so you can read it again yourself. So I would say determine the exact value of, let me write cosine of x plus y if sine x is equal to, I don't know, let me write it 1/3, and cosine y is equal to, I don't know, minus 2/3. And so determine the exact value of this if sine x is this number, cosine is this number, and x and y lie on the second and third quadrants respectively. Okay, I think this sentences can be written in a nicer grammatical way, but you understand what I mean. So what I want you to calculate is the exact value of this combination. I have provided you with some pieces of information. One piece of information is that sine of x is 1/3 and x lies in the second quadrant. Cosine of y is minus 2/3 and y lies in the third quadrant. Based on these pieces of information, I want you to calculate the exact value of this, and I want to give you 10 minutes, okay? 10 minutes, I don't know. If you can solve it quicker, that's much better. But let me pause the video and ask you to do this formula. And let me write important. Probably that's a very good exercise in the book. I would recommend you to start from this one because I think it would be a long problem, yes? Okay, may you please also explain what is your strategy, what you want to do, loudly and clear, yes?
I'm just looking at the addition and subtraction formulas, and
Yes.
This is rule number 3.
Yes.
So I'm just
So this is natural, yes, because if you want to calculate cosine of x plus y according to today's lesson, it would be very natural to start from number 3, yes? Yes?
And so, as we already know cosine of y, we
Yes.
can use this to calculate cosine of x by
Yes.
using this rule. Oh,
Don't worry, I know that you know, so you shouldn't feel stressed, that's important. Just be yourself, okay? Yes, and that's a plus sign, exactly.
yes.
Yes. So that's a really famous combination, and so we have to use this. Why this is natural to use this? Can you explain it to us?
Because we already know what I meant to say, what sine x is, and
Yes.
we can use this to know what cosine of
Exactly,
x is. To
and it
use
is
on
needed.
this.
Why?
Yeah, to
Because
use
we
it.
see here we see cosine. We need it. We need sine. We have it. So, yes, that's exactly what we want to use. Thank you. Okay, continue, please.
And this is just from the formula. And if we look at the example, it says that sine of x is 1/3, and we square it.
Yes.
And this becomes
Yes. Very,
so,
very good.
so cosine of x is equal to the square root of 8/9, and this gives us,
Yes.
and that's equal to
But there is a small flaw in that. Yes.
Oh, it's.
So even the plus minus you should put behind the first one. Yes. Yes.
Here.
Yes. And now, so that's, may you please write it up there. So cosine x is plus minus square root of 8 divided by 3. But which one is acceptable? So far, both of them are acceptable unless we go back to the problem and read the last line.
Yeah, because x lies on the second
Quadrant.
and cosine of x means the x.
Yes.
How do you say? And it's negative.
Negative,
So the
yes.
one.
So, yes. So you see in the exam, if you just write that, even if your answer is correct, you have to show me that you are respecting the last sentence. So you have to put plus and minus, and just any kind of way that you want to represent it, you should say because x lies in the second quadrant and cosine is negative in the second quadrant, this is why I am choosing this one. Okay? And I would write it in this way. So you would write it cosine x is equal to minus and put it in a box. Yes. Thank you. And now we continue
Yes.
with the same strategy.
Yes, with the same strategy, we're going to calculate what sine of y is.
Yes. Yes. But instead we write everything for y.
And this is what sine squared y is equal to 5/9. So to get what sine of y is,
A small mistake.
Oh.
Okay, and then which one do you accept? The positive one or the negative one?
the negative one.
Where is y? I don't see. It's in the third. Yes. Yes.
It's in the third quadrant.
So even in the third quadrant, sine is also negative, so we have to choose the negative value. So please put it in a box. Yes. Yes. And now we finalize the problem.
Yes, we use the initial formula to
Yes.
because we will have all the parts. First, as you can see, it's cosine of x. So what was cosine of x equal to? We write minus 8 divided by 3.
Yes.
And then times cosine of y, and we already had cosine of y, and it was a minus 2 divided by 3. So.
Yes.
And we do minus. And
Minus
sine,
is in the formula. Yes.
yeah, and then sine of x was also in the equation, and it's 1/3.
Yes.
times sine of y, which is
You just
Minus.
calculated that. Yes. Okay, very, very good. And then you just do some simplifications, yes? I think you don't make it so complicated, okay? So you really don't need to simplify it, okay? Just do this. You have to multiply these two fractions. Negative, negative, it becomes positive. So then you put a fraction line. So multiply the denominators. That's simple. Don't make the problem hard for yourself. So what is the denominator first? 3 times 3?
9.
9. Just write 9. And then 2 times the square root of 8. That is simply 2 square root of 8. You cannot write something else. 2 square root of 8. Yes, and then you have negative times negative again.
So it becomes positive.
Positive, yes. And then what happens for the numerator? 1 times, this is a product, yes? You are multiplying 1 by some number. You have already taken care of this negative sign, so you don't think about it. 1 times this one is just a square root of 5, and we don't need to write 5. If you want to continue, you can just write it as 1 fraction with denominator equal to 9. But that is unnecessary, unless you see that there is some hope to simplify it a little bit. And that is your final answer. Okay? Yeah, please. Yeah, thank you very much. So you need to improve this skill. That was very, very good actually. So I really want everyone to participate. So try to work on your brain. Whenever I ask you, come here, it doesn't matter what happens. Of course, I want you to be able to start solving the problems. If it goes really, really bad and you really don't need, I can go home and edit and take that part away. Okay? So if you really think about that, of course, that would be a big trouble for me. But I can do that for you. But I just want you to start practicing. And that is a very, very nice way of describing. And you will learn, by the way, little by little, when you come and present your work, you learn better. Yes? So that's very, very important. And by the way, if you want to learn something in a very good way, even in the future, you have to teach it. Because when you start teaching it, you realize which weaknesses you have, and then you can fix them. And this is why probably, even if you are a professor in university, you just do not do your research. You have a little bit of teaching as well, because in teaching the subject that you are teaching, you will learn a lot. That's very, very important. So we have 2-0 Natur program over Technique program. Yes, Amanda and Zinura. So the next time probably a Technique person can come here and solve the problem. Okay? So the instructive or I don't know, constructive competition is good. Yes. Okay. Now let me ask you one more question. For example, so I don't know, I suddenly jumped to this problem because I saw that problem is in the book, but I left this. For example, can you give me an angle that we can calculate now except for 15? So which angle do you want to calculate? It's sine, cosine, or tangent, or whatever. So let us talk, for example, about which angle. I don't know, 75 degrees. Okay, let us calculate. So 75 degrees is actually not a very good problem because you immediately can connect it to 15 degrees by this complementary. So what kind of angles we have? Any kind of angles we have? So what can we do? Because we have 3 famous angles, yes, 30 and 45 and 60. So apparently if we have this combination, we can have 60 to so what are the other famous angles that we can calculate? I don't think so. 75 degrees are probably the only ones that we can calculate. 105 we also can calculate because that is 60 plus 45, yes? But for example, let me ask you one question here. If I ask you to calculate tangent of 15 degrees, which is for some reason absent in the Swedish books, but is it possible for you to calculate tangent of 15 degrees? So let us not change everything from the beginning. I ask you now, number 2, calculate tangent of 15 degrees. So how do you think about this problem? So might be this is the reason that in your book they haven't talked about tangent. Because in principle, if you know sine and if you know cosine, one more step is to divide them and find tangent. So that's probably the reason behind this logic, that they haven't mentioned a formula. But in other books, you will see a formula for tangent of u plus v. And I will ask you to discover it in the problems that I will design for interested students, which are not compulsory, of course. But how do you calculate tangent of 15 degrees here? Well, I actually told you how to do it, yes? Just repeat it again. So how should I calculate tangent of 15? Yes, Elias?
You just find cosine of 15 and divide it.
And then divide them together. I want to continue this because I think there is something that I want to teach you about some arithmetic, okay? And I want to use a Casio calculator to see there are some discrepancies probably between our calculations and the calculator. And I want to tell you that this is apparently a discrepancy. Okay, so how can I calculate? So let us change this question to tangent of 15 degrees. Oops, I shouldn't have cleaned this, but anyway, hopefully you trust me on that. Just the last example for today. So I want to calculate, my goal is to calculate tangent of 15 degrees, but I already know sine of 15, and I can calculate cosine of 15. And of course, I do not have any separate formula for tangent, but that's not a big problem. I can divide them later. So let us choose the same pair of angles. We chose actually 16 and 45, so let me choose the same pair of angles. So cosine of 60 minus 45. I hope that you trust me on that. If you look at your notebook, the formula for cosine of the difference is the cosine of the first one multiplied by the cosine of the second one plus the sine of the first one multiplied by the sine of the second one. That's the formula. Okay, and then if you go look at the table, cosine of this is 1 over 2 and sine is the square root. Cosine is of this one. Let me just write the numbers. And if I simplify that, it becomes square root of 2 plus over 4 plus square root of 6 over 4. And so this means that cosine of 15 degrees is equal to square root of 6 plus square root of 2 divided by 4. This is what we get for cosine of 15. I have already found sine of 15, which was that number, square root of 6 minus square root of 2 divided by 4. Okay, this we got. So I can calculate tangent of 15 now. So what is tangent of 15? Tangent of any angle including 15 degrees is equal to the sine of 15 degrees divided by cosine of that. So sine of 15 is this, square root of 6 minus square root of 2 divided by 4, and then divided by square root of 6 plus square root of 2 divided by 4. But this 4 and that 4 will be cancelled. So what I get is that tangent of 15 degrees is this number, which I believe it's a correct number. But if you use the Casio calculator, you will not get this number. And I want you to learn how to get the number on the calculator. So you can calculate this. The people who have the Casio calculator or the Texas Instrument calculator that can give you exact values, that probably I will bet on that this would not be the answer in the calculator. Is it? And if one of you can calculate and read it for me. what is the number that is shown on the calculator? Martin, can you calculate this? Martin? Yes?
Minus 2, 2 minus the root of 3.
Simple as that. So the calculator provides this answer. Of course, this answer is much better if this is true. But I got this answer. Okay, I want to teach you this part as well. Why these two numbers are the same? Yes?
Why didn't you simplify it?
Yes, I will simplify. That's what my point. So if you leave it like that, that is not wrong. That's exact value. But if I ask you find the exact value in its simplest possible form, then this is not the correct one. This is the correct one, because I want to simplify that and show you that this is the case. So what can I do? Let me just teach you here. I take a square root of 2 out from the numerator. So it becomes square root of 3 minus 1. And I will do the same thing in the denominator. Yes, is that understandable? So why is that true? Because if I multiply it back, I will get this. If I multiply this back, I will get this. So that's correct. And then, of course, can I simplify square root of 2 with that square root of 2? The answer is yes, because that's a factor, common factor. But still, I am left with this. This is simpler than what I have, but still not that answer. This trick you need to learn. If you want to get rid of this, by the way, this symbol is called a surd sign. Yes? So if you want to get rid of surds in the denominator, so you need to, for example, in this case, I rescale it, so I rewrite it again, and I rescale it by this expression, which makes a conjugate pattern with the denominator. So if you say why this equality is true, the answer is easy, because this is just 1 and I'm multiplying my fraction by 1, so I'm not changing anything. But you might say, what's the benefit of doing that? You will see why. Because this one is multiplied by itself, it becomes the same thing to the power of 2. But if I multiply this by that, it's a pattern. What's the pattern you see here? What's the pattern? What's the name of this pattern? I have 2 numbers added. I have the same 2 numbers subtracted. I want to multiply them. That's a famous identity. Very, very important. Yes, a squared minus b squared. That's called the conjugate pattern. So the conjugate pattern tells me that the first 1 to power 2 is the first 1 to power 2 minus the second 1 to power 2. Now I can use the squaring pattern here. The first 1 to the 2 is 3. 2 times the first 1 times the second 1. And the second 1 to power 2 is 1. And then in the denominator I have 3 minus 1. So 3 plus 1 is 4 minus 2 square root of 3. The denominator is 2. I can factor a 2 out. It becomes 2 minus a square root of 3 divided by 2. This 2 and that 2 are gone. And then you get the answer, which is on the display of the calculator. So this number is completely exact value. But the nicest way of writing it is to writing it so simple. Yes? 2 minus the square root of 3 is the tangent of 15 degrees. Okay. And I think there are good problems and examples in the book. So I would recommend, I would write down which part you read. So we actually gone through 2 pages in the book, and then there is a new set of exercises coming in. Okay? I will write them on Google Classroom, which pages to work and how to solve them. And probably I will publish a set of new problems for the interested students probably today or tomorrow. Okay? Any questions? Okay, thank you and have a nice day.